Good morning, class. Today we're going to take a look at creating our first simple demonstration project using MonoGame. So to start with, we need to make sure that MonoGame is installed, and we install it as an extension. So if we come up to Manage Extensions, we can search for MonoGame. And we should get this MonoGame project template. So these are all the different templates for building MonoGame projects. In my case, it's already installed. You can tell by that green check mark. If you don't have it installed, go ahead and set it up to install, run it. And once you've done that, you can actually create new projects using those templates. So we'll come in, New Project, and we need to find the MonoGame platform, which we can find here in that third category of types of projects. And here are the four templates that we have. The cross-platform desktop application running on OpenGL, Windows Universal application, using XAML or Core App, or MonoGame Windows desktop application with DirectX. This is the one we're actually going to use pretty much throughout the course. This is actually the oldest of all the types of projects because this is kind of what XNA originally started with. And let's go ahead and just call this one Hello Game because this is kind of our hello world of games. We'll go ahead and run create. And like any project, that's going to go ahead and create for us from that template. There is a program, which is our entry point, where the main method is, and you can see in there it constructs an instance of this game1 and then invokes its run method. We don't actually have to do anything with that program, that's just normally there. And it gives us a game class that extends from the game class. And by default, the template calls that game1. If you don't like that, you can go ahead and use rename to give it another name, like our hello game. And if you use the rename option, that means that's going to apply it everywhere. So you'll see the file name changes to reflect that, as well as the class name and the constructor here. So with the MonoGame framework, we have the game class, like I said, that we're extending, and we have a number of hooks into that game class where we override a specific method that gets triggered as part of its life cycle. So we have the construction of the game, we have initialization, the loading of content, so those are called kind of initial steps, and then we move into the game loop where we'll invoke update followed by draw, followed by update, followed by draw, and it will just iterate between these two basically infinitely long until we actually exit the game by invoking the exit call. So if we were to go ahead and run this right now, it would walk through initializing, setting up the graphics card, all the details. In the update, all we really have is some code to exit the game if we hit the back button on a controller, if we're using a controller, or the escape key if we hit the escape key on the keyboard. Also, by default with the desktop application, if you hit Alt and F4, that will also exit the game. And it's important you have some way of exiting the game, because if you're running this in debug mode and you happen to say put it in full screen, it can become very difficult to actually close the game and return to Visual Studio. In the draw method, we have graphicsDevice.clear, so we're clearing the screen or the background, actually the back buffer, to this cornflower blue. And then we're not really doing anything else other than invoking the base method. And this is very important with all of these hook type methods, that we go ahead and run the base method as well. So we have to use base, which refers back to the game class, and invoke its initialize. And you want to do that is the last step of these methods. Alright, so if we go ahead and run this, we should just see a window that's going to have a blue, cornflower blue background. So this is what we end up with. Now this is a little unusual in terms of Windows because the full screen ability is disabled, and so is the resizing of the window. And that's because we have a back buffer that's set to a particular width and height, and we're trying to make sure that our client area of our window is also that width and height. There are ways of overriding that, but you don't want to do that until you know what you're doing, because you'll end up potentially stretching or squishing your scene, because this rendering is actually being done on a graphics card into a back buffer, and that back buffer is then copied into the Windows client area. And if the client area and the back buffer are not the same size, it will automatically basically scale it to fit. And That works great if the aspect ratios are the same. If they're not the same, then you'll end up with kind of a squished or a stretched image. Okay. So what we really want to do here is just demonstrate a little bit of that game loop by animating a sprite that we're going to have bouncing around. And for this, we're just going to create a ball and have that ball bounce around the screen area. So in order to do this, we're going to add a couple new variables to our game. So we're going to add a private, we need to represent the ball's position on screen. We're going to use a vector2 for this. So this is a 2-element vector, kind of like what you've probably worked with in physics or calculus or trigonometry. So I'm going to call that one ball position, and I'm also going to do velocity to mark how our ball is moving around the screen. And then I also need a texture 2D to represent the ball's texture, so what the ball actually looks like. This is the image that we're going to use to display the ball. So I'll go ahead and just set those up as class variables within MonoGame, and then we need to initialize it. And we have the constructor, we have the initialize method, and we have the load content method, and all of these can be used to initialize the game, but they all deal with somewhat thematically different types of initialization. So the constructor primarily is initializing the window and other details like that. So for example, if we wanted our window title to be MonoGame, this would be a good spot to put that code. So the window is a property of the game class that we're inheriting from, which gives us an abstraction of the window, and that can allow us to do things like allowing it to resize, to go full screen, some of that, as well as set the title, which is what shows up in that title bar across the top. Now for the game logic itself, we really want to do that initialization here in the initialize method. So we're going to initialize our ball position and our ball velocity here. So we're going to construct a vector2, and it takes 2 arguments, which are floats, because it's using floats for the x and the y position. And let's say we want to put this at the center of the screen. Well, we have to figure out what that center is, and there's a couple different ways we can get to that. But one of the easy ones is the graphics device, which is another property defined on the game, which is an abstraction of the graphics device. And if we click on that, it gives us a viewport, which is what a rectangle that is the area that we're drawing into. So we could go ahead and say viewport.width and divide that by 2, and that will give us the width of that viewport halved, and we'll do the same thing for the height. So this should be right in the center of that viewport. Now this is an int, this is an int, so we're going to actually be doing integer division, which is fine because that'll give us pixels. Even though we're putting this into a float, it'll be a whole number. So that initializes the ball position. Now we might want to also have it go off in a random direction. And to do random directions, we need a random number generator. And you've probably worked with system.random before. We can go ahead and use that one here. And with games, the random number generator that is the system.random is not generally considered as good as we want. For our purposes in this game, it's perfectly fine, but if you're trying to do some really advanced game design, you may end up wanting to write your own random number generator using one of the better noise algorithms that are a little more costly to run but give you better pseudo-randomness, if you will. But for now, like I said, this will work fine for us. So we'll do ball velocity, and we'll initialize that to a new vector2. And with that, we're going to give it a initial random direction for the x and the y from that random number generator. And we'll go next double. This returns a double between 0 and 1. and that will give us our x and our y. Now notice that because vector2 constructor takes a float and these are giving us doubles, we're going to have to explicitly cast these to be floats. And that's because we're actually losing some precision. We're throwing away some of the finer precision of those doubles in order to use them as floats. And XNA was old enough and ran on the Xbox 360 that they wanted to use the smaller floating point variable instead of the double precision floats. So the matrices and the a lot of the floating point numbers will actually be floats in MonoGame rather than doubles. So when we're using system libraries like this, we're just going to have to do some casting. Now the other thing we need to load is this ball texture, but that's a little bit different because that's basically an image that we have to pull in, and so there's a process for this. And it starts with this content folder. If we open that up, there is this content.mgcb, which is basically a list of all the things that we need to build that are content that we want to pull into the game. And MonoGame and XNA are really interesting that they have this content pipeline that takes the raw files in the format that we may have edited them in and transforms them as part of the build process into a binary file that is ready to be read in by our game. So we need to add new content to this. Now when we do that, we could type in a whole bunch of text commands, but they also give us a nice graphical editor for doing this. So if we go ahead and click on that and go to open with and scroll through our options, this MGCB editor WPF is written for us by the MonoGame folks. It's built on Windows Presentation Foundation and it's really easy to work with. If you don't have that option here, then you need to install it and register it. So go back to the documentation for MonoGame or the lesson notes below and you'll be able to find the instructions for installing that. So if we go ahead and click OK, that gives us this editor, and you can see it's just basically giving us a project kind of window, properties similar to Visual Studio, and then this output window. And then we have a lot of options across the top. The one that we're interested in is add an existing item, because we're going to pull in an existing image and turn it into this binary format we need. So I'm going to go to my download folder, and I believe I have a ball in here. Right there, that one will work. So we open that, and notice it gives us some options to either link to the file or copy to the directory. We want to copy it to the directory, that way it will be added to source control when we commit this to GitHub. That way whoever downloads our game can actually build and run the game as we would expect. So we can go ahead and click add. Now we could build here directly by clicking the build or rebuild, which will basically take this file and convert it into that binary format, but that's also done as part of the regular build process of the solution. So if we just save it, that's really all we have to do. And that's really it for getting that set up. And once we've done that, notice that now this content has a ball.png with a bunch of information about we're importing as a texture, we're using the texture processor, and some information about color keys and all of that. These properties, if we actually click on the ball, actually are open in the property window down here as well. So there's a lot of options that we can do with that, and we'll talk about those in particular with sprites or images in the near future. Okay, so returning to our game, now we have to actually load that into this variable that we've created here, this texture 2D, load that binary content. And we do that in the load content method. So not in initialize, and we have to do it in load content. And the reason we do it in load content is run after the graphics device has been initialized and set up and configured. And with video cards, with graphics cards, we actually have video RAM, so RAM that is actually on the card itself. That's where we want our textures loaded, because that's where we need to use them to actually render them onto the scene. We could also load them in system RAM, but that means we have to copy the bits of the image to the graphics card every time we use it, and that's significantly slower. So we do all our initialization of graphics and other types of content within this load content after we know the system's ready for it. And we do that using a content manager object, and there's actually one that's initialized by the game class by default, and it's stored in the content property. So if we type in content and then invoke its load method. And load is, as we see, a templated method, so we have to define what we're loading, what kind of object we want to load, and we're going to load a texture 2D. And then we have to give the name of the asset, which is basically the file name, without the extension. So if we actually put this in a subfolder of content, it would be the subfolder name / and then the name of the content. But we never put the extension on, and that's because this file, when it gets built into a binary file with the same name, just ball, but it drops the extension, and that's what we'd want to load in here. It also means that if we have a ball.jpg and a ball.png, only one of those can actually be built into that binary form. So all these names need to be different, not just the extensions. So we get that loaded up, and we want to assign that to that ball texture variable. And now that holds that texture. All right, coming down to our update method. In here, we want to handle all of the updating of the game world. So in this case, we want our ball to move around the screen. And it makes sense for our ball's position to be updated by the velocity. And notice that we can just take the position variable and plus add ball velocity, because the vector 2 actually overrides the plus, minus, multiply, and divide operators. So we can use them almost the same way that we'd talk about it in trig or in mathematics, by using the operators directly. If we wanted to do something more like cross product or dot product, because we don't have an operator that corresponds to those, we'd have to actually say vector 2 dot and put into the two vectors that we want a dot product. We also have like multiply, add, as methods defined on the vector 2 class as well, static methods that we can invoke. But in many cases, it's easier to just use this operator. Now, if we were operating with a truly fixed time step that we always knew was going to be the same time step, we could just do something like this. And we don't have to actually worry about time, because every time we update, every time through the game loop, we would know the exact same amount of time had passed. And this is exactly how we would have programmed back in the day of the Nintendo or the Super Nintendo. A lot of those consoles where we knew exactly how quickly the system clock was going to be running. But XNA works a little bit differently in that it does use a fixed time step, but that fixed time step is by default, and you can change this, but by default it's synchronized with your monitor refresh rate, which is usually what we really want. But that means that if our monitor refreshes 30 frames a second, then we're going to have this update called every 1/30th of a second. And if our monitor refreshes every 60 times a second, then we're going to do it every 1/60th of a second. So that's going to change based on the amount of time. And so what we can do is we can take this velocity and multiply it by time by taking our game time dot elapsed game time, which is the value of time that has elapsed between the last frame and this frame. So how long this time step took. So again, if there were refreshing 30 frames a second, this would be 1/30th of a second. And then we want to use dot total seconds, which is that measurement as a double representing seconds. And of course, because it's a double, you want, I think, to put this on the other side. We might have to cast it to be a float. There we go. So now it's happy. So we just needed to cast it. I'm not sure that it matters which side it's on. But we're basically taking the velocity times time, and that gives us our position. So if you remember from your learning trig or calculus, you probably talked about some of those physics calculations or physics formulas, and that's basically one of the simple ones. Now, that updates our position, which could potentially push us off the screen. And if that's the case, we want to actually turn the ball around to make it bounce back into the screen. So let's just start with a very simple example. What if our ball is going off the screen to the left? So we could say if the ball position dot x is less than 0, then we know it has gone off the screen to the left, and we'd want to turn it around. So we could say ball position dot x, and basically if it's going off the screen to the left, we'd want to turn it so it's facing to the right. And we can do that just by flipping the sign. So multiplying by -1 flips the sign, so if it was moving to the left, that's a negative number. Multiply by -1, now it's a positive number. It's moving the same speed, the opposite direction. We can go ahead and expand on this. This is probably what the left side of our screen is going to be, is 0. But if we want to constrain it to the viewport, it is possible for the viewport to be moved around and not actually go all the way to the edge of the screen. So let's go ahead and get the actual viewport. So the graphics device viewport dot X is the left side. And like I said, that will probably be 0. Now, we want to flip the direction if we go off to the left, or if we go off to the right, it's going to be the same. So what we can do is we could actually make this an OR and do ball position dot X is greater than graphics device dot viewport dot width. And we want to also subtract from this the width of the ball, which in this case, the image I'm using is 64 pixels. And also we'll go ahead and subtract 64. And the reason we do that, maybe for legibility, I'll move that up there. The reason we go ahead and subtract that 64 is the ball is like anything we do in screen coordinates normally. The upper left-hand corner of the image is the X and Y position, and then it has a width and it has a height. So here we're just checking that X position, which is the left side, against the left side of the screen. But here we're looking at the right side of the ball. And if we want the ball to be entirely on screen before it starts bouncing, then we have to account for the width of the ball. So that's the 64. And we can do the vertical pretty much the same way. If ball position dot Y is less than graphics device dot viewport dot Y, then we're going to do ball, or if the ball position dot Y is greater than graphics device dot viewport dot height minus, again, the 64, because it's a 64-bit square, or 64 pixel square, then we'll take that ball velocity dot Y and multiply that by -1. And I just realized that I said ball position up here. What we want is the velocity, because we're changing the direction it's moving. And actually going back up here, there is, right now, if we look at this speed now and we consider it in terms of the time that we're updating here, this is seconds times velocity, so our velocity is now measured in seconds, pixels per second. And if we look at this, this is between 0 and 1, this is between 0 and 1. So that means we're looking at less than 1 pixel per second. That's going to be an extremely slow ball. So we might want to pick up that velocity. And before I do that, I'm going to also do ball velocity dot normalize. So normalize rescales this vector so that it's length 1. Because it could be anywhere from length 2, because this can be 0 to 1, so it could be anywhere from 0 to 2 units in length. This makes sure that it starts at standard length, and then we can scale that by multiplying it by a scalar value. So let's do 100 pixels. So this is 100 pixels per second now that we're going to end up moving when we do this. And then if we get off the screen either direction, we're going to turn around and head back. And there is something we do have to be a little careful of. If this ball can move far enough to actually get so far off screen that when we turn it around, it doesn't get back on screen in one frame, which can happen due to floating point error, then we can actually end up in a weird case where it kind of gets stuck on the side and is bouncing back and forth, but never quite gets loose from the side. In our case, we don't need to worry about that. We're moving 100 pixels per second. If you divide that by 1/30th of a second, that's going to be well under this 64-inch width of the ball. So it should never have that particular problem in this case. But if we're speeding up that ball over time, that might be something to be worried about. Alright, now we're just going to finish up with our draw method here. So in our draw method, again, we say we clear this screen out. Now, one of the interesting things about how MonoGame and XNA are actually working is they are using the 3D graphics hardware to do all the drawing. Now, we're working in 2D, so what we're essentially doing is saying we want to have these two-dimensional images rendered in a 3D world. So it's kind of like a cardboard cutout that we're just facing towards the viewer, and you can create a pretty realistic scene that way. But we'd have to basically put textures onto meshes that would be rectangular meshes, or quads is what we call them in 3D rendering. And there's a lot of bookkeeping around that, and MonoGame and XNA actually give us a nice class to help us manage that bookkeeping so that we don't have to deal with it as much, and that's the sprite batch class. And the sprite batch, the reason it's called a batch is it actually batches up a whole bunch of renderings and then actually does them all at once in the hopefully most efficient way it can. So if we get our sprite batch and call begin, and then we'll also have a matching end, we will actually put in calls to draw things in between these. And when we hit that end, that's when they actually get drawn. So up in here, we can put them in any order, and it just kind of makes sense of them. We'll spend a lot of time talking about sprite batch not too far in the future. But for right now, we just know that we need to invoke the draw, and we're going to use the most simple form we can use, which is we supply the texture, and then a vector for the position, and then a color. And this color is used to basically shade that image a different color. So if we use white, it's going to be whatever color it came out of the image. If we use something like color.red, then it would actually have a red tint to it. So we can use this color, for example, if we wanted to have it flash red when it bounced off a wall or something, we could do something fancy like that. So right now we're just going to use white. We're going to use the ball position, and that defines the upper left-hand corner of that image. So then it's just going to draw it to its normal width and height based on the texture that we're using, which is this ball texture. And that's really all we need to do to get our first game up and running. So let's take a look at what that looks like. There we have our ball. It's bouncing off the sides and moving around that blue background, and we have nice animation. So what's really going on here is we initialize, we load everything, we get into our update where we move that ball a little bit, then we clear our screen, draw the ball, and then we come back and update its position, clear the screen, draw the ball again. And we just keep doing this infinitely often, going through this loop until we exit the game. And that's really all there is to understanding kind of the basics of the game loop. There is one piece that you probably noticed is missing from our discussion here that was in your game programming patterns book, and that is this step where we process input. And that's because part of that is actually handled for us by the game class, and we're going to look at how to pull in that input in our next lesson. So that'll be the next piece we need to look at. And that's important because right now this is not truly a game, it's just a tech demo because we can't control anything in that game world, which is one of the hallmarks of a game. So we'll go back and look at input next time.